Well, hello everybody. Hey, this is a lesson on using the cosine rule. In this video, I'm going to show you how to find the missing side or a missing angle of a triangle using the cosine rule. I'm going to show you some tips and tricks, some shortcuts, and a couple things you got to be careful of. So by the time you're done with this video, you should be rock solid with the cosine rule. Now, this is part 2 of non-right triangle trigonometry. If you're really familiar with the sine rule already, you're in the right spot. But if you haven't seen the video, or if you're not real familiar with the sine rule, you might want to pause this video. I'll put a link in the description so you can watch the lesson on the sine rule. That way you can be squared away with all the details that are true for all of these non-right angle trigonometry formulas and rules. Anyway, if you're in the right spot right now, you're ready for the cosine rule, this is how we're going to do it. There's two ways that you see the rule. There's two ways you can use it. You can use it to find a side, or you can use it to find an angle. We're going to talk about all that in detail here. And then when you're done with all those first two lessons, then we're going to just dive into the applications of non-right triangle trigonometry. All right, so first thing first, the biggest detail that people need to be aware of, these formulas, they repeat letters with lowercase and uppercase. The uppercase is usually the angle, the lowercase is the side, and if it's the same letter, like here, angle A is opposite of side A, angle C is opposite of side C. So just keep that in mind. That's true for all of this kind of stuff. All right. Now, version 1 of the cosine rule, well, it looks like this. A squared equals B squared plus C squared minus 2BC times the cosine of A. That's a mouthful, right? Now, there's two ways, as we mentioned earlier, to use the cosine rule. You can either use it to find an angle, and that's if you have all three sides, or if you have two sides and the included angle, well, then you can use it to find the opposite side. So that's actually how this way is going to be used. If you know two sides and the included angle, well, this side right here is already solved for pretty much. All you're going to have to do is take the square root, both sides, and you're done. So let's be really careful with what included means, though. Included means it's in between. So if I had 9.5 and 6.5, this would be the included angle. This angle's not included with those two sides, neither is this. So another way to think about that is the sides, if they make the angle, if where they cross is the vertex, then that angle is included. So it's right in between, just like this right here. So if you had two sides and an included angle, the opposite side is easy to find. This is the formula you're going to use. It's not too bad at all. But before we see an example of that, I just want to make sure and drive home the point that it's really, really important that you identify this fact right here. This angle in the formula and this side right here, they're related. They're opposites. The letters are kind of arbitrary. You're not going to usually see A, B, and C. You're going to see numbers and other letters and symbols and all kinds of stuff, right? But the angle and the side are opposite, and that's what that capital A and lowercase a will be talking about. So it doesn't really matter which angle it is. That's arbitrary, and it also doesn't matter what letter it is. Wherever that capital A is, its opposite side is this A. So wherever the angle you're dealing with is, it goes right here, and the opposite side goes right there. And again, it doesn't matter what the letter is at all. So for example, let's say we had this right here. E is the angle that's marked. So then that means we would plug in E for the cosine of E right here. Which side would you have to use for the value of A? Lowercase a. Would it be M, N, or Q? Well, since M is opposite, we would use M right here. However, if E was over here, right, in this top right-hand corner, that's the angle E. What letter would be A? Would it be M, N, or Q? Well, since Q is opposite, we would put Q here in the place of A in the formula. And last example, if E was this bottom right-hand angle, N is opposite, so N would go here. So the point of all that is that the letters themselves are arbitrary. They're not fixed. This formula shows the relationships, and the relationship you have to get right is the angle and its opposite side. So let's see an example. We have this triangle here. We have two sides, 11 and 6.5, and the angle's marked 88 degrees, and we have to find the side that's marked X. So 88 degrees is our angle. The opposite side is X, so we're just going to plug those things in right there like that. Now what B and C are, they don't really matter. It could be either way. It's arbitrary. You could do it this way, or you could switch it around, do it the other way. You're going to get the same exact answer, right? So step one, you're going to identify the parts, and you're going to plug them into the formula. Step two, you're going to take the square root of both sides and simplify as much as you can. It's easy. Write it down on paper. Be very, very patient and very, very careful. There's lots of signs to deal with. This sign right here, this could be positive or negative depending on which quadrant the angle's in. And squaring numbers, adding them, you got to be really careful. Take your time. When you plug things into the calculator, make sure you don't round too early. This one rounds to 3 significant figures, 12.6. So take care. Lots of details, lots of signs, and order of operation errors just kind of laying in there for you to mess up on, right? So just take your time and be patient. But you can handle the first version. You got that. Now let's talk about version 2. Version 2 is when you're going to use this formula right here to solve for an angle. Now, I'm going to show you the steps that were used to change this into version 2. You don't have to do these steps every time. Sometimes you do, though. Like maybe this is the only formula they give you, and you're going to have to maybe know how to solve for the angle. Well, first thing you do is you subtract b squared and c squared from both sides, like this. And then you would divide both sides by negative b, 2bc. You'd divide both sides by negative 2bc. Now, nobody likes a negative denominator. We don't need all that negativity. And positive numbers are prettier anyway. So we're going to multiply both sides, top and bottom anyway, numerator, denominator, by negative 1. Clean that up a little bit. This right here is the other way that you see the formula. So on a reference sheet, you'll usually see one or both of these, right? They both come from the same thing. This has been solved for the angle A to get that. Well, the cosine of it anyway, and that's how it would look. All right. So let's see how that would work right here. If you had all 3 sides and you needed to know an angle, this is what you'd use. Now, if you wanted to solve this for A, you would have to, of course, take the arc cosine of both sides, and this is what you'd get. And often I start with this instead of this. It's already solved for A, not too bad. And the only thing you got to be careful of is lowercase and capital A are an angle on its opposite side. The capital is the angle, the lowercase is the side. So let's say this was angle A right here in the bottom right hand corner. Do you see which of these sides would be A? Well, it would be the opposite side, which would be 4.3. So this would have to be 4.3 right there. So step 1, you write down the formula and you plug everything in, being very careful of that. All right, now, just like last time, you got some calculator work. You're going to have to be careful of the order of operations and the signs. When you square 4.3, it's going to be minus whatever that is squared. Be really careful. This negative is not being squared, just the 4.3. And this one right here would round to approximately 44.9. And I don't know why I gave a straight up equal sign here, whereas in the last one I gave the approximation to show it was rounded. Oh, man. Might get some trouble for that. Anyway, last thing, right? So we talked about rule 1, we talked about version 2 of the rule. So let's just review what we've got so far. If you want to find a side, the best way to do it is if you have 2 sides and the included angle. Then the cosine rule is absolutely no problem. You can just plug in the numbers. You got to be careful of the details. However, where people get into trouble is in a situation like this. They need to know this side, but they don't know the opposite angle, and there's not a really quick and easy way to find it. So in a situation like this, you can use the cosine rule, but it's ugly. It gets really, really ugly. It's better to use the sine rule a couple of times and do a little bit of arithmetic instead. Here, I'll show you. So check this out. Let's say we had a triangle like this, 3.1, 3.8, and x are the sides. And we have one angle, 47 degrees. Well, when you use the rule, when you use the formula for cosine, this and this are fixed. X and 3.8, they could be B or C, but they're not going to be A. So that means they're going to be really difficult to solve for. So if I said X was B, then I would have 3.1 squared equals X squared plus 3.8 squared, that would be C, minus 2X, because B is X, times 3.8 times cosine of 47. This thing is quadratic, so that means you're going to have 2 solutions. It's going to be time-consuming, all kinds of just pitfalls and mistakes. So I would not do that at all. Instead, what I would do is I would use the sine rule. I would try to figure out what this angle is right here, right? Because I know this pair and I know this side. So I could figure that angle out. Once I figured that angle out, I could figure out this angle by just subtracting those two from 180, right? And once I knew what that angle X was, then I could do the sine rule again, and it's not too bad at all. So if you have the 2 sides in the included angle, use the cosine rule. Otherwise, I'd suggest not to. What about finding the angle using the cosine rule? So the angle, man, it's a little more straightforward. If you have all three sides, it's easy pickings, right? If you have all three sides and you want to find an angle, the only thing you got to be careful of is how to set it up. Which is going to be lowercase a, 5, 7, or 6? Well, that depends on which angle you're looking for. So if you're looking for this angle, that is lowercase a, and you would just plug it in. Do the math, be careful on paper, and you're rock solid. So you use this one on the left to find the missing side, and you use this one on the right to find a missing angle. And the thing you got to be really careful of, though, is what you need here is you need two sides and the included angle. So you need this, and then this is, if you have the angle and its opposite side, then you're good to go, right? Over here, what you need, if you want to use it to find an angle, you need all three sides. All right? So my question for you to think about, to make this understanding a little bit permanent for you, how can you tell if you're going to use the sine rule or the cosine rule? Man, that's a tricky thing to describe, but go ahead and give it a shot. I hope this video really helped you to learn how the cosine rule works, give you some shortcuts and some understanding, some things to be careful of. Hey, until next time, I'll talk to you later.